welcome to our tutorials. Today we want to be looking at the characteristics of chemical reactions. Now when we talk about characteristics of chemical reaction, there are some important characteristics I would like to introduce to you, and I'll go straight to the point. The first one is what we call the change of state. Change of state. I'll list them, then in the next slide I'll start explaining them one after the other. Change in states, that's the first one. The second characteristics of chemical reaction is what we call change in color. Don't worry, I'm going to be explaining everything in this chemistry video tutorial. Change in color. Remember, we've already started tutorials on how to write chemical equation and the rest of that, how to form the equation and how to add physical states to equation. We've talked about all that. Today we will be looking at characteristics of chemical reactions. So the third one we're going to be talking about is evolution of gas, evolution of a gas. And then I will end it with the last two, which the fourth one is going to be change in temperature. I will be explaining also change in temperature. Change in temperature. And when I will be done with that, the last one, which is the fifth one I'll be explaining, is formation of precipitate. Formation. A lot of you may not know what that means. Formation of precipitate. Precipitate. Most of you don't know what is precipitate. If you know that, put it in the comment section right now. But these are the 5 characteristics of chemical reactions I'm going to be explaining in the next slide. And I hope you're ready for me. Is change in state. Now let me give you a typical example of what we call change in state so that it makes everything about this tutorial to sink in your brain. Change in state, the typical example is when you're burning a candle. When you're burning a candle. So what really happens? Let's assume, pardon me, I don't know how to draw, but let's assume this is a candle. This is a candle, and let's say this is the flame. I know what happens when a candle is burning. You'll be seeing some stuff falling off from the body like this, right? I think you understand what I'm trying to say. All of those things is what I want to use for this particular explanation, and I'm sure you're going to enjoy it. Now, example is burning of candle. A candle is made of, this candle you're seeing is made of wax. The body of the candle you're seeing is what we call the wax, candle wax. It's made of wax. Candle is made of wax, which is solid. This wax we are talking about is solid, is in its solid state, is strong, is in its solid state, it's not liquid. You know that already. It's solid. The wax itself is solid. Now when you burn the candle, due to the heat, when you burn this particular candle, due to the heat, when you're burning like this, due to the heat that comes out, it will form what we call the molten or liquid wax. This thing that is falling is what we call, either I call it molten. If you've been hearing molten state in chemistry, molten is the same thing as liquid state also. Let's put it, or liquid wax. This same wax that is solid, you start seeing the liquid form of it, liquid wax. The liquid wax is always somehow hot, but it's something we can touch. All right, some people like playing with it because it's not too hot that it will have to burn your hand. Some people, that's why sometimes you pour it on the floor so that it can be able to pin this particular candle. So that liquid is also coming from this wax because of heat. That's what resulted to that liquid wax. Hope you understand. Tell me now, hope you understand what I'm trying to say. So I was saying that during when you're burning, during the heat, because due to the heat, molten or liquid wax is produced. This is produced due to heat. liquid wax or molten is produced. And this production of this thing is what we call change in state. You can see that it has changed from the state of solid to this liquid wax. That's what we refer to as change in state. Now, when the candle burns, gas is evolved. When this particular candle is burning, gas is evolved. You see gas evolving like this. Gas will be evolving like this. All right. So when gases are produced, the candle burns to give carbon dioxide or carbon dioxide. Carbon dioxide, which is CO2. What was the statement that brought about this? Some of you didn't pay attention. Okay, listen again. I say when gases are produced, the candle burns to give us this particular carbon dioxide. Not only carbon dioxide, and also water vapor. Water vapor. It produces carbon dioxide and water vapor. Water vapor. So which is maybe the H2O. Water vapor, I still mean water. All right. And then both of these are gases. Both of these are gases. Both the carbon dioxide and this water vapor, they are gases. So you can see that we have literally changed the state of solid to this gaseous state during when we have heat produced or when this candle is burning. So that's what we mean by the term change in state. It has changed from one state to another. I hope that makes sense. We are still on the characteristics of chemical reactions, and this is in number 2, which talks about change in color. And I will use this particular example. Maybe I may use another example if this does not click, but I will make sure to explain this one in more detail. I will do a lot of repetition to make sure everything is well explained. Let's consider citric acid reacting with potassium permanganate. Potassium permanganate. Keep in mind, you're going to be hearing dangerous names and names some of you are not used to. Some of you must have heard about this one, but we're going to be using them. My job is to explain what these things are and what the reactions you ought to expect. And maybe when you get to your lab, you can be able to see more from your lab technicians. So let's think about this as when tomatoes, tomatoes you use in cooking. I don't mean the tin tomatoes, and I don't mean the sachet tomato. Please, if you're using those two, tin tomatoes and sachet tomatoes, to make your stew, start avoiding them. It's not healthy. Think of anything that is preserved, anything that has a expiring date is never meant for you to be consuming. So that tin tomatoes and sachet tomatoes, you don't need them. Go and get fresh tomato. I know it might be expensive, but just make sure you stay healthy. That's what I'm trying to say. So just think of I'm talking about the fresh tomatoes. When tomatoes ripens, like when it gets ripe, it changes from green to real color, isn't it? To red color. I mean, tomatoes changes. Fresh tomato. It changes when it ripens. When it ripens, it changes from what? From green. Originally to be green, it changes from green to what? To red. To red color. We are talking about change in color. Now, for example, this potassium permanganate has purple color. This particular one, it has a purple color. Purple. It has a purple what? Color. So when citric acid, this citric acid is acid you get from either orange and etc. I'll talk about this more before I end this particular video. So when citric acid is added to it, is added to this potassium permanganate, what happened? There is a chemical reaction that takes place. So that chemical reaction that takes place will bring about the solution that changes everything to in fact, the color will now change to colorless. Everything becomes colorless. The solution becomes colorless. Immediately, citric acid is added to potassium permanganate. It becomes colorless. So when this one is added to this, Remember I said this is purple color. So when this citric acid is added to this purple color, you will not see color again. It becomes colorless. Now let's talk about it very well. When we talk about change in color, a change in color means the substance reacting produce a new substance with a different color. This is direct sign that chemical reaction has happened whenever I see that the color has changed. Now let's bring it back to something we understand or we know, we use every day, like banana. Think of banana. Banana. Banana definitely usually change from green to yellow to brown. It changes from green to yellow to brown. So when banana ripens, enzymes react with chemicals inside the fruit. Enzymes react with chemical inside the fruit. I mean enzyme. You know about enzymes. Enzymes are organic catalysts. They usually don't start reaction, but they speed up the rate of chemical reaction in the body. Enzymes react with chemicals inside this particular banana, inside this particular fruit. Now, when they react, new substances are formed, causing color change. New substances are formed, causing color change from green to yellow because chlorophyll breaks down. When chlorophyll breaks down, what happened? Then the next one, yellow, from yellow to what? To brown, because new chemicals like the chemical here, I think is melanins also. Can't remember the name, but I know the spelling. I think it's melanins. Melanins will be formed. So new chemicals, because of new chemicals, it will change from what? From yellow to brown. This is very, very simple. This is what is happening every day, but most of you are not aware of it. I'm just telling you the chemistry of it. But when you get to your classroom chemical example, like when you want to do your practicals, that's when they consider using this potassium permanganate, which the formula is potassium permanganate. You may have seen this in textbook before on your chemistry. This is the formula for this potassium permanganate. And this potassium permanganate is always dark purple liquid. Like I told you, it's purple color. It's a dark purple liquid, often used in labs and water treatment. They usually use for water treatment and also in the lab. But when we talk about this citric acid is the acid in orange, lemon, limes. You usually have this sour taste and it's safe and natural. So if you're eating, that's why they say if you're having ulcer, you know when to eat orange and all of those things. You know what to avoid and all of that because it contains acid and you know the time to eat it as well. Even lime and lemon, as the case may be. So the acid that is found in those fruits I mentioned, like orange, is what we call citric acid. Citric. Do you understand? And it's safe and natural. It's not like something that will burn you when you take it. All right. So what really happened in the reaction? What happened in the reaction when you add acid, like the citric acid from lemon or orange juice to potassium permanganate? The purple color disappears. This purple color we are talking about, it will disappear. The solution turns colorless. Why? Because a new substance forms that does not have the purple color. This is a clear sign that the chemical reaction has taken place. I hope this is well satisfactory. The explanation is very, very detailed and you understand what that means. So we're going to be moving over to the next one, which is evolution of a gas. That will be number 3. And until then, I'll see you. Take care. And this is one of the characteristics of a chemical reaction. Please do not forget. I'm going to spend time and I'll do a lot of repetition on this one so that I want everything to enter clearly without any form of confusion at all. Now, when we look at when we're talking about evolution of a gas, for example, if I have a zinc reacting with maybe hydrochloric acid, this will definitely produce zinc chloride plus hydrogen gas. In this case, this hydrogen gas is a gas. Now, when we talk about evolution, what exactly is evolution? Let me keep it simple. Evolution means gas is evolved. Evolution means, let me write it clearly, gas is evolved. So meaning that gas is produced, it is produced. It is produced. That's a literal meaning. That's what it means. Anytime you hear of the word evolution, it means gas is evolved. Now, zinc reacts with hydrochloric acid to produce zinc chloride and hydrogen. That means hydrogen is the gas in this particular case. This hydrogen gas you're seeing is the gas in this particular reaction. Hydrogen is evolved. That's what it means. This hydrogen being the gas, it has evolved. That's what this evolution of a gas means. I could give you a couple of examples. Like for example, if you have iron, reacting with sulfuric acid, why am I even writing the name of this thing? I should write it in compound form. Okay, let me just finish up with this one. This will produce, let me just put it in this form, iron Fe. It makes sense like this when we write stuff like this. React with hydrochloric sulfuric acid, which is S2SO4. Please, this is sulfuric acid. At least you learn more with this particular pattern. This will produce FeSO4 plus hydrogen gas. You can see I'm indicating gas in this particular point. So you can see that this is the hydrogen gas that will be evolved whenever iron react with sulfuric acid. I can even give you another one. Say maybe example, we have sodium. Let's say sodium carbonate, which is written as Na subscript 2 CO3. Please let me write it clearly. Let me write it very well. CO3. So if this sodium carbonate reacts with hydrochloric acid, HCl, is definitely going to produce sodium chloride plus water plus maybe carbon 4 oxide. So in this case, this carbon 4 oxide is the gas. That is evolved. Carbon 4 oxide now is evolved. Do you understand what it means now? If you like, you can balance this particular equation because it doesn't look balanced the way I'm seeing it. Because we have nitrogen 2 here, sodium 2. Here we have just single sodium. Even hydrogen, we have it 2 here. Here we have single. So if you want to balance this, it's simple. Just say N, this particular one remain the way it is. Na2CO3 plus just add 2 to this guy to balance the hydrogen on the left hand side. Yeah, because here is 2 over here, just add 2 in front of this one. So you have NaCl. Then plus this one is also already okay because we have 2 hydrogen over there. Then plus CO2. The equation is balanced. But if you check this Cl over here, we're having it as 2, and then over this place we have just single one. Then if you check this other part, we have Cl to be 2 as well. Over here is 2. That means everything here is balanced. So we are saying in this particular equation, this carbon dioxide is evolved, so it is a gas. So whenever a chemical equation takes place, sometimes one of the product formed is a gas, which is one of these products that is formed. One of them is a gas, like this one, as we've seen, hydrogen in this case. Here, carbon 4 oxide is a gas. So when this happens, we say that there is evolution of a gas. You usually notice this by the presence of bubbles. Or maybe fizzing, all those kind of sound, fizzing, or maybe hissing sound, fizzing or hissing. Any I want to do, it. That's what we mean by. That's how you easily notice that there is gas. Once you see gas being released during a reaction, it is a clear sign that a chemical reaction has occurred, because gases do not just appear on their own without a chemical change taking place. Do you understand? So this is always common every day, because for example, if maybe when baking soda reacts with vinegar or maybe lemon juice, immediately they are mixed together, bubbling starts. So those bubbling are not air, they are not air at all. They are carbon dioxide gas being produced as a result of the chemical reaction. So the formation of the escaped of this gas is what we call evolution of a gas. You understand? You can also look at a standard laboratory example when maybe hydrochloric acid also reacts with calcium carbonate. Maybe hydrochloric acid, another example, reacts with calcium. Calcium, sorry, let me write it very well. Calcium carbonate is CaCO3, calcium carbonate. So when hydrochloric acid reacts with this calcium carbonate, it will produce calcium chloride plus water plus carbon dioxide. So this particular one is found, this calcium carbonate is found in chalk that they usually use in writing the board, or marble or limestone. Gas is produced. You can see gas is produced, the product. The chemical equation is this one you're seeing. So hydrochloric acid reacts with calcium carbonate to form calcium chloride and water, and at the same time carbon dioxide is released. Then the bubbles you observe during this reaction are the carbon dioxide gas escaping into the air. So this release of gas confirms that the chemical reaction has taken place. I hope this is quite simple. So we'll be looking at the next one, which is change in temperature. Let's look at that in the next slide. Peace and love. So the next one is change in temperature. Let's look at this particular one real quick. So if we have maybe quicklime is a calcium oxide. If this quicklime reacts with water, H2O, this will just give us a slake lime plus heat. Slake lime is CaHOH sub 2 plus heat. This is what we call slaked lime. Slaked lime. Please write these things down. This one I told you is calcium oxide. This calcium oxide is a quicklime. Calcium oxide. I told you it's a quicklime. Quicklime. This one is water already, you know, and then it will form heat. It will form this one, slake lime and heat, when this one reacts with this one. So in this case, this heat that is produced, this heat that is going to produce is the temperature. That's the temperature increase here. Pretty simple, right? That's change in temperature. Now, in some chemical reaction, there is a noticeable change in temperature. The reaction may become hot or it may become cold. This happens because energy is either released or absorbed during the reaction. When reaction releases heat to the surrounding, like in this particular case, the temperature increases, and such a reaction is called an exothermic reaction. Maybe that's another topic I will teach sometime. And then a familiar example is the burning of fuel. When you're burning fuel, such as cooking gas or firewood, heat is given out and the surrounding becomes very hot. A good laboratory example is the reaction between calcium oxide, which I just did, also known as quicklime, and then this water. The chemical equation will produce this particular one, which is this slake lime, and heat will be released. That's laboratory reaction, like preparation. So this calcium oxide reacts with water to form this particular calcium hydroxide, and heat is released. If you touch the container of this particular if you touch the container, you feel that it has become very hot or hot. This increase in temperature shows that a chemical reaction has taken place. On the other hand, some reaction absorbs heat from their surrounding. This reaction causes a drop in temperature, and that one is what we call the endothermic reaction. I've told you about exothermic and endothermic reactions. And a pretty example of that, an example is when maybe certain salts salt to use, table salt, such as it might not be table, it could be ammonium chloride dissolved in water. And when ammonium chloride dissolved in water, what happened? And the solution becomes cold. Hello friends and welcome. So this is the last one, which is formation of precipitate. And this is one of the characteristics of a chemical reaction. And like I explained others, when it comes to this one called the precipitate, a precipitate is a solid substance that forms when two liquid solution react with each other. Let me just break this one down. Let me just keep it as simple as I can. Now, when I say precipitate, let me start with that one, because this word, some of you don't even know what it means. I will talk so much about this before I now explain the formation of precipitate. So bear with me, because my classes is based on simplifying everything. I don't want any student to be confused. Now, when we mention the word precipitate, let me use another color. Precipitate. Precipitate means, I'm not writing everything, so you just be active to write. Means a solid that forms when two liquids. Let me write that clearly. When two liquids, it could be two liquid, or it could be two liquids, or I can just call it a liquid and a solution. A liquid and a solution are mixed together. I will not be doing more of writing so that I can be able to explain this speedily. Are mixed together. But just be active to follow what I'm saying. Are mixed together. Okay, so we are saying precipitate means a solid that forms when two liquids, either it could be two liquid or it could be a liquid and a solution mixing together. Now, what happened when they mix together? And a reaction will definitely happen. A reaction is going to happen that will produce an insoluble substance. That insoluble substance that will produce an insoluble substance will be produced. That insoluble substance is what we refer to. And what is this insoluble substance? It's something that cannot be dissolved. Something you cannot dissolve in the liquid. So you just imagine two things are mixed together. That thing that refuses to dissolve, that's what we mean by insoluble solid or insoluble substance. And that's what we refer to as a precipitate. Maybe you didn't get it clearly. Let me use a kind of an example that will make everything sink for you. Let's say a solid that will appear as a small particles that sink, like when you drop a solid inside water, let's say a gravel or a stone, you drop it inside a bucket of water. What happened? It will sink to the bottom of that container or make the liquid look kind of cloudy. All right, let me that stone there is what we refer to as precipitate, because it will never dissolve inside that particular water. Or just imagine you add powder milk. At least everybody knows powder milk. You add powder milk to water, but instead of dissolving, some of you take tea now. So when you when you visit somebody's house and then they serve you, give you tin milk and bonvita, and then there is bread for you to dish those stuff by yourself. Some of you you will scoop like 4 spoons of the milk, right? When you scoop it and pour it inside that, whether hot water or warm water, do you notice something when you're taking the tea? You notice that when you check down, there are some that cluster. There are some of the milk that clusters, that refuse to dissolve inside that particular water. They will just form something like, some of them will even form like clumps that will be flowing on the surface of the water. Some of you may have noticed this in several ways. It could be in your house, it could be somewhere else. You understand? Some clumps like that stays at the bottom, some floats. That clumps is kind of like a precipitate. That's what that thing that refuses to dissolve. It's kind of a precipitate. That's what we are calling precipitate. But the difference is that in chemistry, the solid isn't just undissolved powder. It is formed during a chemical reaction. That solid is formed during a chemical reaction. For example, you mix silver nitrate. Let's take it in chemistry format. For example, if I use silver is Ag, isn't it? Chemistry student, are you there with me? So if you have silver nitrate Ag, which is silver nitrate, NO sub 3, which is an aqueous solution in this particular case. If you have a silver nitrate solution with maybe that reacts with let's say sodium chloride solution, that's Cl. All right, sodium chloride solution. What happened to it? This is also an aqueous solution. This will produce to produce this one, which is a solid. I'm just trying to balance the equation real quick, which is solid plus and NO3, which is an aqueous solution as well. Good. So this is what it will produce. Now what happened? This AgCl, which is a silver chloride, this is silver, this is chlorine. A silver chloride is insoluble in water. It forms a white solid that sinks or floats around this particular liquid. I mean this guy that is produced when these two things react together. Do you understand what I'm trying to say now? This in chemistry, that's what happened. So that white solid is what we refer to as a precipitate. I hope you understand what precipitate is all about. I've tried to see how far I could simplify this for you. Now let's come back home. Now potassium, let's use the example, say maybe potassium reacting with potassium iodide reacting with, this is I please, K is for potassium iodine, which is when they are reacting together becomes iodide, not iodine this time. Potassium iodide plus lead, that example I wanted to give you. This lead NO3, lead nitrate will produce this one. We produce this particular one, KNO3 plus PB. This equation is not balanced. I'll balance it anyways. So what I'm about to say is that a common laboratory example again that you can think of is the reaction between this lead nitrate solution and potassium iodide solution. That this is a chemical reaction or the chemical equation. All right, so what now happened? The lead nitrate reacts with this potassium iodide to form this particular lead iodide and potassium nitrate. This is potassium nitrate and this is lead iodide. I think some of you want me to write these things out. You will not want to tell me. Let me just write it down. Potassium. This one is potassium iodide. This is potassium iodide. Did I spell it correctly? I don't think so. Let me make the correct spelling of this thing. Iodide. That's iodide. This is correct now. So potassium iodide plus this one is the lead nitrate because of the nitrogen you're having there. Lead nitrate, when it combines with the oxygen, that's why they call it lead nitrate. So we said that lead nitrate reacts with this potassium iodide to form lead iodide. This one is what we call the lead iodide, and this particular one is what I refer to as the potassium nitrate. So this lead iodide that I mentioned here, this lead iodide is a yellow solid. This guy is a yellow solid, and it appears immediately when the two solutions are mixed. This yellow solid you're seeing here is what we call the precipitate. The sudden formation of this of a solid from two liquid reacting together clearly shows that a chemical reaction has taken place. So when we talk about the characteristics of chemical reaction, we look at signs such as evolution of gas, we look at a change in temperature, We looked at the formation of precipitate, and the change of color. We've talked about those ones, and the rest of that. So whenever one or more of these sign is observed, it confirms that that is a chemical reaction, or a chemical reaction has occurred. I hope you found this particular video tutorial. Please, some textbook, when you see something like PPT like this is a short form of precipitate. I'm just thinking about some things that will be helpful when you see them in exam. PPT is a short way of writing precipitate. So this reaction is formed. This reaction we just did now forms a precipitate. You see a precipitate that is formed, which is this guy, and then that's something I want you to know in this particular video tutorial, and I feel you understand everything because I simplified it. I hope you enjoyed today's class. Take care of you. See you.